Hello, everyone. Welcome to another edition of Hailing Frequencies Open, presented by the Nichelle Nichols Foundation. I'm Mike Wong, and it is my honor to be your host today. I'm a planetary scientist and an astrobiologist at the Carnegie Institution for Science's Earth and Planets Laboratory in Washington, D.C. I'm also the host of Strange New Worlds, a science and Star Trek podcast, and I'm a lifelong Trekkie. I'm a fan of the entire Star Trek universe, but the most special show to me is the one that I grew up watching, Star Trek Voyager. So it's my true pleasure to be joined today by Tim Russ. You probably know Tim as the actor who brought to life Lieutenant Commander Tuvok in all 7 seasons of Star Trek Voyager, and more recently, Captain Tuvok in the 3rd season of Star Trek Picard. What you may not know is that Tim is also an amateur astronomer, a member of the Los Angeles Astronomical Society, and a contributor to Griffith Observatory and the Planetary Society. Thanks for joining us, Tim.
My pleasure. Thank you for having me.
Today, we are also joined by Dr. Kayla Iacovino, a volcanologist, meaning that she studies volcanoes, not Vulcans, at NASA's Johnson Space Center. In addition to being a scholar, Kayla is a fantastic science communicator who has appeared on NPR, PBS Nova, the BBC, CNN, and a humble little podcast called Strange New Worlds. Kayla is also on the editorial staff for TrekMovie.com, your one-stop shop for Star Trek news. I'm so excited to speak with you again, Kayla.
Excited to be here.
Great. Well, today, Tim, Kayla, and I are going to talk about our mutual passions for outer space, exploring strange new worlds, and seeking out new life. But before we get to that, we have a very special message from Marion Smothers, the chairman and president of the Nichelle Nichols Foundation. Marion, please take it away.
Thank you so very much, and thank you all for being here. It's good to see you again, Kayla, and so nice to meet you, Tim.
Yes, nice to meet you as well.
Absolutely, yes, I'm excited to be here. We've had some things that happened in the last couple of weeks that we're really excited about. We finally got our designation for 501c3. So since we have that designation now, we've created 2 partnerships. And I'm going to just briefly tell you about them. First, we're now a partnership with an organization called Benevity. It's a platform that thousands of companies, corporations use for their employees who want to contribute part of their earnings to charitable contributions. So if your company uses Benevity platform, they'll match 100% for whatever your donation is. It's a great way to donate, so please check to see if your organization, if your company rather, if it uses Benevity for their platform. Also, we are now an approved nonprofit with Microsoft. They have a search engine, you may be aware of it, called Bing. If you go on to givebing.com, you can go in and make the Nichelle Nichols Foundation your charitable contribution. And every time you use Bing as a search engine, you rack up points. Now the points will convert into cash money for your contribution and to the Nichelle Nichols Foundation if you sign us up as your charitable contribution. Again, these are great ways to donate. It helps us a lot, and it helps us to be able to do what we are very ambitious program that we are trying to do with the Nichelle Nichols Foundation. So thank you all for being here. I'm excited to hear from you and hear your stories. Thank you.
Awesome. Thank you, Marion. I am really, really proud to be associated with the Nichelle Nichols Foundation and all of the good work that it does, increasing accessibility to space and the space sciences for everyone. So let's get on to our Q&A with our panelists, Tim and Kayla. First question is for you, Tim. For many years, of course, your day job was to portray a character on Star Trek whose mission is to explore strange new worlds. But then you'd go home and spend your nights looking up at the night sky through your telescopes. Tim, how did you get into astronomy, and what is it about outer space that speaks to your soul?
Well, I started pursuing astronomy as a hobby pretty much out of the blue about 35 years ago. I just decided, I was sitting around, decided, I'm going to go buy a small telescope and take a look at the planets because they were visible within the city along with the moon. And I had never really owned a decent telescope in my life. So I thought, well, I'm going to go out to find one that's really, a starter sort of telescope that I can actually see the planets on, and sort of got started doing that. And then I decided I wanted to learn the night sky. At the time, there were no computerized consumer telescopes that were available. So everything was manual, and you had to actually know what you were looking for and what you were looking at, using books and charts and things like that. So I did that. And I was always fascinated with space science to begin with. I was a fan of science fiction, also science as a study for years. So I decided just to be hands-on with it and start looking at, the planets and the moon initially, and then eventually deep sky objects, because of course, once you started down that road of buying telescopes, you just keep going, and, you end up with 7 or 8 of them before you know what happened. So, and this was years before Voyager. I was always interested in it, and I decided to pursue it as a hobby, pretty much on my own. And later on, I got to meet other people who were also interested, but it was just something I did, and it's still going very strong today. And it's coincidental that I ended up on a show, obviously playing a character who was in a sci-fi space type series. It's just coincidence that it happened that way.
Yeah, I resonate so much with that because I actually decided to major in planetary science in college when I took a field trip with one of my classes to the Lick Observatory, and looking through that giant 36-inch refractor telescope, this very intricate telescope that, like you said, you had to slew by hand. You had to know what you were looking for, and being able to peer through that scope at Jupiter and its 4 largest moons, what we call the Galilean satellites, that image just hitting my eyeballs through that magnificent scope really persuaded me to go into the space sciences. That was a magical, moving experience for me.
Yes.
I was wondering if you could describe some of the emotions that you feel when you look at some of your favorite astronomical objects.
Well, the very first one that I looked at was through the telescope eyepiece was Saturn, and I was just blown away to be able to see the detail on that planet with a relatively small telescope at the time. And continuing on, it's still one of my favorite objects to look at because it's very easy to see, obviously, in the city, and and you can really delineate the detail on it, even some of the cloud bands, when you've got a nice still night and a decent sized scope to look at it with. Right now, I'm working with what's called the Unistellar EV scope. The company Unistellar makes it, and they have a wonderful, basically a consumer level imaging telescope. It's everything built into one. You don't have to have a lot of accessories and parts and pieces and things like that. And it's part telescope and part sort of an imaging processor. So it looks at objects deep sky and it layers the light from those objects, so that the objects become brighter and brighter, and they're easier to see. And these are deep sky objects, things like nebulas and galaxies. So, and you can see them from the city as well with the city lights. It filters the city lights out also. And so now my favorite objects to look at are the deep sky objects, the galaxies in particular, the Whirlpool Galaxy being one. There's the Cigar Galaxy, there's the Eagle Nebula. See these with the naked eye within the city, again, the city limits of Los Angeles, which is, incredible because of the light pollution. That's really been some of my favorite things to view today. And that's only because of the technology that's now available to people to get into, and relatively simple to operate, because I prefer the learning curve to be that of a rock with a light switch. I like it that simple, So I'm very, very happy to be able to see the deep sky objects, some of the things that they're showing now. Some of those objects have been taken with this telescope within 3 or 4 minutes, by the way.
That's amazing.
Yeah.
That's just wonderful. As a planetary scientist, I'll try not to hold it against you that you traded a planet for galaxies as your favorite astronomical objects. So, Kayla, you traverse the globe not looking up at the stars, but actually at the rocks beneath your feet. As a scientist, why is it essential to understand our very own planet Earth if we were to truly understand our place in the universe?
Yeah, so I'm a geologist, and like you said, I study volcanoes in particular, but all kinds of magmatic processes. And when we're thinking about things on a planetary scale, that ranges from a volcano to planet formation itself. So from the earliest formation period of our solar system, we started out with a bunch of things colliding together, creating these molten worlds where we had literally what we call magma oceans. There's a planetary stage where the entire surface of a planet is molten lava. And then, all the planet evolves from there. So all these processes I study have to do with everything from the earliest planet formation to how planets are resurfaced. And a lot of my background is I work now at NASA Johnson Space Center with Jacobs, studying more and more planetary things. Earlier in my career, for the first 10 years of my career, I was mostly focused on Earth geology, Earth volcanoes. And I think it's important to have both perspectives. More and more, we're getting people who are more specialized in the space aspect of things. Back in the day of the Apollo missions, all of those scientists were Earth geologists. We didn't have moon rocks at the time. We didn't have specialists like that. And so I think having that dual perspective is really important. And the great thing about Earth is that it's easy to access relative to other planets. So we can get a ton of information, a ton of data. We can go pick up a rock. There are plenty of planets in our solar system that we don't have rocks from. For example, Mercury or Venus, we don't have any meteorites from those places. We have meteorites from Mars and meteorites from the moon and rocks from the moon. But these other places, we rely on observations from satellites and telescopes. Telescopic observations have been a huge way we collect data. And so we're getting all of these, photons hitting the Earth, and we're collecting this data in light, essentially. But how do we understand what that means in terms of what the rocks are made of, how they got there, how they evolved to that point? And when we have Earth as our analog, we can go out, we can pick up the rock and see, well, okay, what kind of light does this emit if we shine an infrared laser at it or a UV laser at it? And so using Earth as this sort of baseline of understanding is really critical to interpret any of the data we get from outer space. And the other reason it's, you can ask the question two ways, because a lot of people say, well, why do we spend money studying outer space? We have so many problems here on Earth, right? My first answer to that is that the two are not mutually exclusive. We live in a society where we're lucky enough to live in a society where we can do such esoteric things as science at all. And we can do both space and the Earth. And the reason we want to look to space is because that tells us where our place is in the universe. How our only data point in terms of life, for example, is the Earth. It's the only place we've found life. But what does that mean? Is it unique? Is there other life? Or is the evolution of life inevitable on typical planetary surfaces? Or is this a fluke? Is this, catching lightning in a bottle? Is this super rare? And where are we on the spectrum of possible life forms that exist in the entire universe? So both perspectives, I think, are really critical for just, again, understanding our place in the universe.
Yeah, absolutely. I think most people think about volcanoes as these scary things that are very detrimental to life. You wouldn't want to be near a volcano when it went off, but could you just briefly explain why we think volcanoes would be essential, an essential part of a habitable planet, an Earth-like planet?
Yeah, so with the recent data coming back from the James Webb Space Telescope, which is like Hubble's successor, we're able to capture all these data from really far off exoplanets, planets outside of our solar system. And volcanoes have become this big thing in the exoplanet world, which I think is awesome, because volcanoes are the things that deliver all kinds of chemistry from the inside of a planet to its outside. So if you have a planet without volcanism, it has that magma-ocean stage, it cools and sort of freezes, and then it's done. That's it. If you have volcanism, that surface of the planet is continually being recycled. So nutrients that life needs to thrive gets recycled onto the Earth so it can be reused by nutrients. And atmospheres get produced. We put things like water, carbon, sulfur, all these things into atmospheres of planets. And so, we kind of have to pick some feature to say, well, maybe there will be life there, right? We like to narrow down our field. And so exoplanet researchers are trying to find signatures of volcanism, chemical signatures of volcanism in atmospheres of exoplanets. So they look for things like sulfur or water or some thick atmosphere around an exoplanet. And that's sort of the first hint that, okay, maybe we should look more at this planet because we know it has an atmosphere. There are chemicals that indicate there's this volcanic recycling activity. So maybe Earth or maybe life could thrive there. So.
Yeah, you might say no Vulcans without volcanism.
Exactly. New catchphrase.
So, Tim, in 2021, you and 5 other citizen scientists were credited with aiding NASA in the detection of Patroclus, one of the Trojan asteroids orbiting the planet Jupiter. Tell me a little bit about this really cool work, and what does it mean to you to have contributed to solar system exploration?
Well, I was invited to participate in this sort of mission, as it were, and there have been some missions that have followed that have been very similar. They're doing them now again, sort of on a semi-regular basis because of the citizen science program with, again, the telescope that I have. I could not have done it without, using this piece of equipment, the unistellar EV scope. So because of this scope is able to track asteroids, we were able to do the occultation, which is the asteroid crossing in front of a star. And NASA had the Lucy mission, which is on its way to examine the Trojan asteroids. Those are the ones that are within Jupiter's orbit. And the probe is just going to fly right by them. It's not going to stop and orbit and study them. It's just going to go by them. What they wanted to do was get an idea of the size and shape of these asteroids before the probe got there. So they asked us to do the occultation, which is basically just imaging the asteroid as it crosses in front of a star and the shadow that it casts on Earth. They are able to use that data to get an idea what the shape of the asteroid was. And I did it here, not that far from my house, where I could see that part of the sky. It took about 4 minutes to get the exposure, and it was done. And with the telescope, I send the data to the Unistellar company. They crunch the numbers and they send back the video. And what you get is basically a light curve, which shows a level line, and then it drops down, and then it comes back up again when the asteroid crosses in front of the star. And they were able to estimate part of the size and shape of the asteroid just from doing that. And several of us did it across the country, that wherever the path of that asteroid occultation was taking place. So it was very cool to be able to do that. I had never done anything like that before, and that was absolutely amazing. Consequently, we can also track exoplanets with that telescope as well. Again, it'll take hours to do that, several hours because of the transit of the exoplanet, but it will also create a light curve showing you when the planet crossed in front of the star and how long it lasts. It'll do the same thing. So I was very happy to have a chance to participate in that project with them, again, because of this telescope and how easy it was to be able to accomplish that mission.
That's so wonderful. Yeah, I was thinking as you were describing the technique for this Trojan asteroid that this is exactly how we detect so many exoplanets out there by the shadows that they cast on their stars.
Yes.
And this technique, of course, also allows us to peer into their atmospheres, connecting this to what we were talking about with Kayla before, detecting exoplanet atmospheres. As that starlight filters through the atmosphere and into our telescopes, we're able to pick up the molecular signatures of whatever might be there, CO2,
right.
or
industrial industrial elements that might be
What,
done, created artificially. Oh, who knows?
one day maybe we will. Yeah, that would be exciting. But yeah, also maybe a sign of a planet whose civilization may not be taking too good care of their atmosphere. I wonder if any aliens are looking at us and thinking that very thought right now.
Yeah, yeah. Wow, that would be absolutely amazing.
Yeah.
Absolutely amazing. On the day. On the
Mhm.
day.
So Kayla, in Star Trek, science is one objective of the Federation, but another is also maintaining galactic peace and harmony. And I know that one of the coolest places that you've gone to do your field work is North Korea, a place where very few Americans have gone. So tell us about your experience doing research in North Korea and whether or not you think that science has a major role to play in building bridges across geopolitical divides.
Yeah, well, the answer to your last question is absolutely. So this was a project in the early to mid 2010s. I went there in 2013, part of a big group that I was lucky enough to sort of be added to after about 2 years of logistical planning had been done. I was at an institution in the UK at the time. I was at the University of Cambridge, finishing up my PhD. And my PhD advisor and some of his colleagues had been, like I said, spending 2 years between the UK embassy, the Chinese embassy, and the North Korean embassy, working out all of the plans to allow us to go there. And the reason that we were going there is because there's a big volcano right on the border between China and North Korea. The political border actually goes right through the crater of the volcano. It's a huge volcano, but very little is known about it because obviously it's really difficult to get to study. And there was a series of earthquakes beneath the volcano that indicated that it might be moving around again, and people wanted to take a look at that. And so people from within North Korea actually got in contact with the principal investigators of the project. So my supervisor, Clive Oppenheimer, and his colleague, John Hammond, and asked them to come and collaborate with them. And so we got a group and went over there, and really this was a 50-50 operation. 50% like, let's go do the science. This is amazing access to understand this volcano, but very few people have gotten to go to. But the other half of it was this this geo policy, basically this extending an olive branch and seeing if we can't make the relationships between the West and North Korea a little bit better. And I think it works really well when you're approaching it from a scientific angle, because the idea is that you're all scientists there. We worked with North Korean scientists in the country. We were scientists. We were there for science. There were no flags. We weren't there representing our state government. We were there not really representing officially anyone. We were there to work together and learn about each other and learn about each other's perspectives. Anywhere you go and do field work like that in another country in particular, one of the most crucial things that you learn as a scientist, which they don't really teach in class, is to work with the people who live there, scientists or not, because those are the people who are living with that volcano or whatever it is that you're studying. They're the ones who are going to be affected by any of the dangers. They're the ones who are going to be affected by any of the positive things. And they're the ones who know the history of the area. They know where the best rock outcrops are. They're very valuable people to ally with. And it's, we want to avoid any kind of imperialistic attitude when we go to other people's countries. We are a guest there. And so I really learned a lot about that side of doing science, being there. There's nothing like being in another country or being in another culture to start to glean some understanding of why they are the way they are, why they view the world through a certain lens. What are they seeing on television? What is it like to eat in a restaurant? What is it like to walk down one of their streets? What is the weather like? All these different things are kind of making these people who they are. And using science to do that, like I said, it kind of releases the tension on some expectation of a political partnership or worrying about the response of a government. And you can really just get to know people and focus on working together.
Yeah, as you were describing your experience in North Korea, I kept on thinking, wow, this is prime material for a Star Trek episode. Maybe some kind of story where there's a strange anomaly inside of Klingon space or Romulan space, and the Federation has to, go and scientifically try to help understand what is going on, but at the same time tell the story about building bridges, understanding truly who those other people are, and trying to, walk in their shoes for a little bit and understand their perspectives.
Yeah, absolutely. That's pretty pure Star Trek right there.
Yeah, definitely. So, Starfleet's mission is not just to explore outer space, strange new worlds, but also specifically to seek out new life and new civilizations. So, for both of you, what do you think are the most promising locations for looking for new life or search strategies for looking for extraterrestrials? Maybe we'll start with Tim and then go to Kayla.
I think the current plan that we have with the Webb telescope, and that's looking at exoplanets around other stars. They were initially looking at red dwarfs because there are so many more of those stars and they last for so much longer than the average stars like ours. But they were very volatile, so that they've had issues with trying to find a star that's settled in that realm. So now I think they're looking more at stars that are like our own sun, where the Goldilocks zone might be a little bit more narrow, but the star would be stable and give the planet a chance to. I think that's the way to go. I think that's what they're doing right now, is analyzing the atmospheres of these planets, because if we can go through hundreds or thousands of these planets and be able to analyze their atmosphere, I think that's going to be the easiest and quickest way to identify a planet that may have what is an industrial civilization signature in the atmosphere, with the chemicals and things like that they could find. I think that's the quickest and easiest way to do it. Apart from UAPs that the Air Force pilots have been identifying. Apart from that, I think that in terms of just the science of searching, I think that's the best way. My hat's off to SETI, who are looking for signals from other planets and civilizations. That is one way, but I think the fastest is going to be the James Webb and just looking for planets that have an industrial signature in their atmosphere. I believe that we will find that. I don't think it's going to be easy, and I don't think, honestly, in this galaxy, just our galaxy alone, that there are going to be that many. From what I've heard, by estimates from astrophysicists and other astrobiologists, and I don't pitch in on this, but I don't know that there are that many, as one might assume, in our galaxy, simply because of the odds of life, coming to fruition on a planet and developing into an intelligent civilization or advanced civilization. That not only them being able to get that point and not destroying themselves, and or that civilization simply, coming to an end over millions of years, and no longer being there. So it's very difficult to, I think the odds are very, they might be a little more thin than what we might hope. As Kayla was mentioning earlier, it's possible that we might be very rare in this circumstance in terms of the biology coming together and us developing and evolving into an intelligent species and a species that can study and explore the universe, as it were.
Yeah, I'll just chime in there and riff off of some of the things that you mentioned, Tim. That was a great answer. First of all, I'm a big fan of exoplanetary science and exploration, and of course, JWST, that James Webb Space Telescope, is giving us unprecedented data about planets. Like you were mentioning, a lot of surveys have been targeting these red dwarfs. The reason for that is because that they are the easiest to try to characterize the planets that orbit them. Unfortunately, exactly as you said, a lot of these red dwarfs tend to be very volatile. So they're sending off these solar flares at frequencies and rates that just unparalleled for stars like our own sun. And the danger for that is that these very frequent solar flares could strip away atmospheres from terrestrial planets the size of Earth. There's a particular system called the TRAPPIST-1 system that people may have heard of. It's a fabulous system to study because it has 7 roughly Earth-sized planets orbiting a red dwarf. And we're using JWST to now look for atmospheres around those planets. And it looks like, at least for the closest planets orbiting that star, we can't detect any atmosphere. So it's a little bit disappointing, but also points to this perhaps truth that these stars are a little bit too volatile for their planets. Now, the jury is still out for the farther planets, especially those planets in the habitable zone, but that data is coming, and we're really excited for that.
Excellent. Cool.
Kayla, how about you?
Well, I love that I have a different answer.
Yes.
Because I mean, there's no wrong answer, right? Every way we look is great. But one of the, so I'm thinking about life in general, not necessarily intelligent life. And partly because, let's say we find some signature that we think may be life in an exoplanet. The first hurdle is verifying that and really interpreting that data correctly. And the second one is, even if we can really prove it, they're going to be so far away that even communicating with them might be difficult. And I'm greedy, so I want to find life that we can see and maybe even touch. So I'm looking right here in our solar system. I am super hyped about like the Europa Clipper mission. So the moons of Jupiter and Saturn both have some promising moons. Enceladus, Europa, these icy worlds that may have a thick ice crust and then potentially a very thick ocean, liquid water ocean underneath. It could be a brine, a salty ocean. And if that's true, you know, NASA's motto for decades has been follow the water, because we've picked that thing as we know we need that for life on Earth. So let's use that as a constraint. So I'm really excited for those missions coming up to look for life here in our own solar system. Maybe even Venus, I'll throw it out there. I know there was the whole atmosphere thing recently that turned out to be a bit of a bust, but we know so little about Venus. Like, we haven't even observed that there's active volcanism on Venus. Like, we're pretty sure that there is. I would put money on it, but we haven't had a direct observation of that. And it's like, it's right there. It's easier to get to than Mars, but it's hard to study because, you know, it tends to melt the spacecraft that we send on it. And it's difficult to see beneath the clouds. So, but go Venus. Let's have more Venus missions and Europa and Enceladus missions.
And you've got underwater, the underwater vents that would be under these oceans on planets like Enceladus or Europa because of the friction caused by the orbital pattern of the planets, the Jupiter and Saturn in those cases, that are basically, you know, compressing and expanding those planets back and forth, causing those underwater vents like we have in our deep oceans as well, which could be, you know, what keeps the water not only liquid, but also potentially a habitat for life as well, just like the ones on Earth. And I would be fascinated to see what an underwater probe on Enceladus would turn up. I can't imagine how cool that would be. And I know you couldn't imagine. That would be insane to see that.
Totally insane.
Yeah, that would be insane. And I have to agree with you. Yeah, our local solar system, just to find, as you said before, signs of life outside of Earth. Just something crawling around, something that you could see, whether it's under a slide in a microscope or whether it's actually crawling around or swimming around or whatever on an ocean. That would be amazing. And it would confirm a lot of things right off the bat. That would be the story of a lifetime, really.
Yeah, I mean, confirming we're not alone in the universe, even if it's microbes that are.
Even if it's microbes, yeah. Life can exist elsewhere. Yes. Yeah.
Yeah, that would be such a profound discovery. And Kayla, I'm so glad that you brought up Europa and Enceladus, because those are some of my favorite objects as well. Exactly as Tim said, they seem to be ripe for an origin of life with these hydrothermal settings. That is one prime candidate for the geochemical setting where life may have begun on Earth. And we know that at some of the hydrothermal vents at the bottom of Earth's ocean, the biomass there, the prolific nature of those ecosystems rivals some of the rainforests at the surface of the planet. But there's no sunlight at all. They're feeding off of chemical energy coming from those rocks. It's absolutely astonishing. And searching for life on those worlds, like you said, is going to be no small feat because they're buried, those oceans are buried under tens of kilometers of ice. But hopefully, with the Europa Clipper mission, which Kayla mentioned, launching next year in 2024, which is a cool Star Trek connection to the 2024 crewed Europa mission that was depicted in the second season of Star Trek Picard. I don't know if the writers maybe took inspiration from the actual NASA Europa Clipper mission launching next year. That would be really cool to know. That mission will give us an unprecedented glimpse at the surface of this icy world, and hopefully give us good indications of habitability and maybe even signs of life. Kayla, you also mentioned
they're going to fly this Clipper into one of the vents. Is that right? On the bottom, is it going to Europa or Enceladus? The Clipper.
It's going to Europa.
They want to get inside the under the ice with this craft. Is that
unfortunately this one will not. So it's more of a reconnaissance mission. It's going to orbit Jupiter and then do multiple close flybys of Europa. Okay. The reason why it can't go into orbit of Europa itself is because Europa actually exists in this torus of ionized radiation around Jupiter, trapped in Jupiter's magnetosphere, and it wouldn't survive very long there. The spacecraft wouldn't survive very long there, so it actually has to make these wide orbits around Jupiter and make these very quick flybys of Europa.
Got it.
And yeah,
got it.
And there's also the European Space Agency's JUICE mission. Yes. Which, can I just side note, say it used to stand for, I think it was Jupiter Icy Moons or something, like Jupiter and ice, but they had some really contrived acronym and they dropped the acronym and it's just called JUICE now. And I just kind of love that because I'm so sick of these acronyms that make absolutely no sense. That are totally dropped. Way to go, Europeans, for just calling it JUICE. It's just a JUICE. And that's launched. That launched not too long ago.
Nice.
Yes, that's right. That's right. Yeah. So, NASA and the European Space Agency are at it, sending probes into the outer solar system and also to Venus, which Kayla, you mentioned. There are 3 new missions going to Venus, 2 from NASA, 1 from ESA. And they should, hopefully lift the veil on that cloud layer that is really shielding us and honestly giving me quite a bit of a headache, because one of my projects is to try to understand Venus chemistry, and honestly, nobody understands Venus chemistry. It's really hard. So hopefully these missions can give us some more data that will solve.
Are they going? I mean, the Russians have been the only ones that have successfully landed, really, and gotten a Venera craft that on there and gotten pictures. Pretty amazing images, actually. Of the surface, albeit brief. Is this the mission that's going to Venus now? Are they going to be landing on the planet, or is it cloud? Are they going to be going through the atmosphere and studying more of the atmosphere? The ones that are going there now?
I believe 2 of them are going to be orbiters, but one of them is going to drop a probe through the cloud layers. I don't think it is supposed to land on the surface or spend very much time active on the surface, but it will descend through the atmosphere and make measurements in that atmosphere of the cloud layer and the chemistry going on there, and hopefully teach us a lot about, those gases that would be coming from those volcanoes, and also potentially some of the gases that were implicated in a biosignature in 2020. So namely phosphine, this gas made of phosphorus and hydrogen that a team from I believe with folks from MIT talking about how this may be a sign of life in Venus's clouds, and that's a speculative hypothesis. It definitely needs more testing and follow up, and so the missions to Venus will hopefully let us know what is actually going on there. Excellent.
That's excellent.
Yeah.
And just to give people some idea of how crazy awful the surface of Venus is in terms of life, for like human life, it's something like 800 or 900 degrees Celsius, so hot enough to melt lead, and the pressure is so intense that the atmosphere, which a lot of it is CO2, gas in the atmosphere actually isn't a gas anymore. It's a different state of matter called a supercritical fluid. So it's like this thick, weird atmosphere. And again, at like 900 degrees, I don't know what that is in Fahrenheit, but over 1,000 degrees Fahrenheit. So yeah, it's pretty crazy down there.
Yeah, in fact, if you're coming through the atmosphere of Venus you won't need a parachute darn near, because the atmosphere is so thick, you'll come down very slowly. It's because of what it's made of, which is really weird. But you don't need a parachute to land on Venus. It's you're going to be held up by the atmosphere so much. It's crazy. It is a crazy place.
Yeah, and because of that, people have talked about the idea of life, like with this phosphine thing as well, but for decades, of life living in the cloud layers.
Yes.
So maybe there's,
Somewhere in the top upper levels, some mid to upper, somewhere in there.
Yeah, maybe there's like a Goldilocks
floating
zone
around
stratigraphically. I don't know. We just don't know.
Perfect temperature. Yeah, perfect temperature. Maybe a little sunlight getting through. We don't know.
Yeah, some nutrients kind of convecting around.
Going around, and yeah, could be.
Yeah, could be. There's so much in planetary science because we're so starved for data that my favorite new thing, like I said, I was mostly an Earth scientist in the last 4 or 5 years, have moved into planetary. And my favorite thing is when I start talking about an idea like this with my colleagues, we just start going, well, maybe, could be, maybe. And that's science.
Absolutely. Yeah, I guess we ought to shout out to the species 10C from Star Trek Discovery's 4th season, these creatures who lived in the gas layers of a gas giant atmosphere, which harkens back to a paper that Carl Sagan actually wrote in the 1970s. He called them the floaters and sinkers of Jupiter, speculating that there might be an ecology in Jupiter's atmosphere. And so, the jury's out. Maybe there is. Maybe there's something floating in Venus's atmosphere. All we can do is send more missions to go find out.
Yeah, I think it would probably come down to the speed of the winds in Venus's atmosphere, and I don't know. Have those winds been clocked in the atmosphere of Venus? Have they been clocked at a certain speed?
Yeah, I don't know exactly the number off the top of my head, but Venus's atmosphere is doing something called super rotating. There is some mysterious force that we still honestly don't quite understand that is blowing those winds at a faster speed than they ought to be. So it's just yet another mystery about our planet Venus. And this is actually a key point that, I think is kind of sobering for the exoplanet studies, is that we still have so much to learn about literally the planet next door, all these mysteries. And we have the luxury of being able to send a spacecraft to these planets, get to taste their atmospheres and map their surfaces. But for those exoplanets, we'll never be able to, unless we invent warp drive, tell your engineering friends to get on it, because we need that warp drive to be able to get up close and personal to these exoplanets. So where I really think exoplanets give us a leg up in terms of the search for life is their sheer numbers. As you said, Tim, that the statistics that exoplanets can give us as we look at them as an ensemble, not necessarily just one planet here and trying to figure out exactly what's going on that particular planet, but just mapping and surveying the possibilities that could be out there altogether might give us hints at trends in planet formation, or looking for trends that might indicate that there is habitable processes going on elsewhere in the cosmos.
Yeah. It's going to be thousands. Yeah, we're going to have to look at thousands and thousands of them to get them. Not unlike what the Kepler does. Just to find them, we have to now survey them at that same speed or that same rate, if it's possible to do so. It'll make a big difference, in the primary candidates. I mean, they can pick them out, but we got to go through a bunch to get it going. It's that simple, and that's just our backyard, basically.
Indeed. Tim, you also mentioned SETI very briefly, so I wanted to let people know about this really cool project that's going on called A Sign in Space. Basically, an artist and a couple of, I believe, computer scientists put together a message encoded that only they know. So like 2 or 3 people in the entire world know the meaning of this message. And then they asked one of the spacecraft on Mars to beam this message towards Earth as a sort of practice for receiving a message from an intelligent civilization elsewhere. And now universities and scholars and researchers all around the globe are trying to decode this message, not knowing what it means at all, and working as hard as they can to try to figure out what it says. And then there's going to be a conference, I believe, in a few months where they all reveal what they think the message says, and the people who actually know what it says can check if anybody got it right and interpreted it correctly. So this is it ties straight into the Nichelle Nichols Foundation, because Uhura was, the communications officer who had to translate all these alien civilizations' languages into messages that the crew on the Enterprise could understand. And we are trying to practice that right now. We don't have the universal translator yet, but we're working our hardest. It's not just a scientific conundrum, but also a linguistic and artistic conundrum that we have to battle here. And we're doing our first practice run now. So that's called a Sign in Space, and I encourage everybody to look that up.
Interesting. Are they basing it on a is it a mathematical message, or is it a pictograph type message? Do you know what they use as a medium, as the type of message that is being sent, or is it?
That's a good question. So that's one thing that I think the people who are receiving the message, and I'm not one of them, so I don't know actually what it contains, will have to try to figure out. It could be a pictographic message encoded in math, or some series of transformations that we aren't quite sure what it is yet. But I think there may be some kind of pictographic element to it based on the glimpses that I've seen of online forums and things like that. But this is an ongoing project. Yeah. So I look forward to seeing what happens.
Interesting. I've not heard of that, but I'm going to keep my ear to the ground and see what happens with that. That is a fascinating experiment. Really Indeed. Is. Because it's coming from, they had to create this message being, people from Earth, being human, to create a message that a human could not easily translate, yet it's a message. So right. And it's coming from a human perspective, even though it might be something that a cryptographer would have to figure out. I would imagine a cryptographer would be the first in line to try to decipher a language of any kind, because that's what they're experts at, to find the patterns and things and be able to interpret them. But just in general, SETI getting a message from another world, I can't even imagine how complex or difficult that would be, simply because of the evolution of that civilization and where they've gone, and or how advanced they may be. I mean, it's possible that some of the civilizations right now out there that are so advanced that they're beyond anything that we would understand, that they could be bombarding us with messages every day. We would never be able to pick them up or understand them, simply because the medium that they're using, we have never developed yet. And we don't know, we don't know how we would interpret these things. We're still using radio messages and picking up signals that way, and analog or digital. It's just, maybe they've gone way beyond all that. Maybe it's just light of some type. Maybe it's, some kind of radioactive energy, something that we're not able to interpret or read. I mean, who knows? That's, oh man, it's crazy. Maybe they're communicating through time. They're that far advanced, you see. We would never be able to interpret that. So,
right.
Wow.
It's hard. It's hard to imagine, right? It's hard to imagine.
Very hard.
Just a few decades ago, I think it would have been hard to imagine the kinds of technology that we carry around in our pockets every day today.
Correct.
Except, that's where science fiction comes into play, because Star Trek is very famous for being forward-looking, predicting things, technologies that we now have. And so I think this is why, as scientists, it's always very useful to take a break from science and go and read a little science fiction or watch a little Star Trek, because that helps us expand our minds and open our minds to possibilities that we're haven't imagined yet.
Absolutely. Agreed. Yeah,
I think a lot of people don't realize how much creativity there is in being a scientist. And it's a different kind of creativity, than being in the entertainment industry, for example. But it's using a part of your brain and then, like you said, expanding the horizon beyond the box. And interpreting data is really the part that takes a trained scientist. So you can collect data, you need to learn how to do the methods properly, but really that interpretation of understanding of what are these signals telling us? As a geologist, we read the layers of the earth like the pages of a book. And it's all there. The earth is telling us, all of these things. Other planets are telling us all of these things. We just have to know how to read it. And it really takes a level of creativity to be able to open your mind to what the possible, so that's, there's another thing to think of translating. It's like a translation, but in a whole different parameter space. Instead of in language and digits, you're thinking in, multi-component chemistry space. So yeah, it's really, you can think of it like being a translator for the Earth and for the other planets.
Yeah, and what if the scientist has to ask the question, what if, before
Absolutely.
considering the data or anything else? It's the creative, I think, comes from the what if. Why is this? And what if I look at it this way? What if I look at it that way? What if this thing that's happening here is actually this or that? And then you have to go find the data to support the concept. But you have to imagine what that could be. I mean, why is it doing this and why is it behaving like that? Well, maybe it's because of this, or maybe it's because of that. And that's not, you're not basing that on any data right there. As you start out, you're basing it on imagining what this could possibly be. And then then you have to go prove it. Yes, of course. Yeah.
No, absolutely. That's a great point. I mean, you're just describing the first two steps of the scientific method, right? Observation and then hypothesis.
Hypothesis, right. Yeah. Yeah.
And I'm sure that is exactly what's going through the minds of the writers of TV shows like Star Trek. That what if question. That's almost the starting point for any science fiction narrative.
Absolutely. Yeah. Taking a concept, a scientific concept that we're already familiar with, and turning it on its head. Whether it's time travel or gravity or whatever else might be, communication, alien species on other planets or other worlds, the culture of these civilizations. Just take it and go, what if? What if what we assume is ABC is not ABC? And we find out later on, simply because of the evolutionary track of this particular race, their culture has turned out to be what it is, due to their civilization or due to physical anomalies on their planet, et cetera, whatever it might be. And that what if just turns everything on its head, completely upside down. I know we've done it on Trek a number of times. And to me, I agree that it's still my favorite, generally my favorite genre, because of the unlimited sort of window of imagination that you can pursue with science fiction. You can step, like Kayla said, out of the box. You step out of the box to tell the stories. You don't have to be in the box. You can come at it from any direction or any angle and turn it sideways like this. And all of a sudden, that whole thing looks very different than what you thought it was. And that you can't beat that with a stick. I mean, that to me is that gets me up in the morning, or at 12 o'clock noon, whichever comes first.
Keeps you up at night, right?
Keeps me up at night, yes.
There you go.
Yeah. I was just thinking in terms of that sign in space and the ways that people communicate. In my brain, I'm thinking music and math, is supposed to be universal. So I'm imagining that code must be maybe in some kind of mathematical equation, or maybe music.
I hope it's a Dolly Parton song.
Wouldn't that be great?
9 to 5, baby.
Yeah.
That's great. That's not a bad, that's interesting. Yes. What if it was music, some kind of a melody that can be translated? That would be very interesting. And if an alien race, communicated through music and not through this sort of speech that we have today, but it was done through some kind of sounds and just melodies. Oh man, I can't imagine. But yeah, it's a great point. And how would you interpret it?
It's almost like we need an astronomer, musician, actor who's played an alien to help us figure out what they're saying.
Fascinating. Absolutely fascinating. I look forward to seeing the results of that experiment. I really am. I'm very curious about it, because I've always thought of what it'd be, how complicated it would be to interpret another civilization's language, signals or signs or whatever it is they would broadcast. It would be fascinating. If you were standing right across from them, I mean, how would that possibly be? Not only, how they would look and appear to you, but, how would you begin that whole process? I don't know. It's crazy. I think one of the stories I read a long time ago that this actually happened, where the people on Earth had to try to figure out how to communicate with this object that had landed right in the middle of the city. a city block, and it was clearly extraterrestrial, but they wanted to try to communicate with it. So they started with the using the elements, the basic elements, elemental tables, and starting with the first element of the table, and then the response was the next element of the table, and then they went back and forth. So they established at least a very rudimentary sort of understanding based on the simple elements that we would find from, in the universe, on the planets and things like that. So it's interesting. It worked out pretty well. But yeah, I mean, what would you use as a template, as a basis? Crazy, man. Not my job.
Yeah.
I'll read about it. I'll read about it when it's done.
And it's cool. It seems like the effort is sort of the opposite of the golden record that Carl Sagan helped develop, that went out on the Voyager
Yeah.
probe. Yeah, I think there they used various things like that. I don't know if they were used elements, but I think, prime numbers.
Yeah.
I maybe was in there. So it's like these certain mathematical constants that if you are sufficiently advanced to, especially to be spacefaring,
Sure.
you must be pi, for example.
Yeah. Mathematics, you would have to be, if it is the assumption is if it's a technological civilization, that they would evolve along a similar track as ours. They are tool makers. You have to be able to make tools. And so we would assume that whatever their path was, whatever speed at which their evolutionary path took, that they would start out obviously as microbial and eventually evolve into something, beings that were intelligent. And once they reached the intelligence level of being able to communicate with each other and to organize and to make tools. Once you get to that state, now we're off and running. And if they could develop that technology, would logically develop along a similar path, and then eventually they would discover a radio and things like that, and potentially become spacefaring over time. That should be the. I mean, I think that's what I think they just don't. It doesn't go from microbial to spacefaring like overnight. I think there's a path that has to be followed, and so it stands to reason that communication would be something in terms of another civilization that's maybe slightly ahead of ours, if not along the same point in time, but maybe a little farther ahead. We'll at least have a background in that and could understand it. And it'll be like that, I think, for the next few hundred years. It should be pretty close to that. So interesting. It'll be interesting to see.
Really cool.
I've always wondered about UFOs, and now more and more people are talking about UFOs and sightings and stuff.
Mm-hmm.
But based on everything that I'm hearing from you, I'm starting to wonder if that's really true. Are we at that point? Do you think that there's civilizations out there that are more advanced? It doesn't sound like it from what I've learned today.
Wow. It's well, that would be probably the planetary scientist sort of point of view on some of that. Mine, I'm not a professional. I don't have a degree in those sciences. I could only have an opinion about them, and whether the UAPs that have been witnessed, viewed, and reported on by pretty credible sightings and radar backups. I mean, there may be something happening. Michio Kaku is one of my favorite physicists, and he said, you might have to keep an open mind. Here's my theory on all of that, because the hard physicists, the people who study physics and stuff, they generally aren't going to comment on things like that, because there's not a physical, as a scientist requires, physical evidence and proof that's definitive. But here's my take on that. Columbus could not get to the moon based on the technology that existed at his time. Wind. He could not get to the moon on that. We now can get to the moon. So 1,000,000 years from now, what would the physics be? What secrets would we unlock technologically to be able to do just about anything? Perhaps travel in time, perhaps travel interdimensionally. We're studying multiple dimensions and universes right now. And every time we've studied stuff in science, most of the time it's come true. So one has to wonder if there was a civilization able to traverse time and space, and as a machine planet, would send out robots, just like we're sending out probes to other worlds in our solar system right now. What would keep them from sending out probes through time, through space, through whatever it might be, to study other worlds? All automated. Who knows? Like I said, You know, the ancient Egyptians couldn't go to the moon. Columbus couldn't go to the moon. We can go to the moon. And it's just a matter of, to me, of relativity, if you will mind using that word. It's a relative situation. 1,000,000 years from now, 500,000 years from now, what will the capabilities of humankind be? We won't even be humankind 500,000 years from now, will we? Probably not. We will have evolved. And what we have evolved into, would that allow us to travel through time and space, or to warp space, or whatever it might be? The big place out there, man. There's a whole lot of space going on. So I don't know.
Fascinating.
I think that is a wonderfully optimistic and mind-expanding place to end this panel. Thank you all for joining us on Hailing Frequencies Open, presented by the Nichelle Nichols Foundation. If you enjoyed today's discussion, or just feel like empowering young women and people of color to explore space for themselves, consider donating to the Nichelle Nichols Foundation. One of the many cool things that we're doing is raising funds to send young women to space camp next summer in Huntsville, Alabama. If you're interested in that, again, please donate. You can find out more information about the foundation at nichellenichols.foundation. I want to give a sincere thank you once again to Tim Russ and Dr. Kayla Iacovino for joining me today on Hailing Frequencies Open. I'm Mike Wong, and until next time, live long and prosper.
And I would just like to say, have a safe and happy 4th of July weekend.
Same, everyone.
Thank
Yes,
you.
absolutely. Nice meeting you all. Thank you. Take care.